Good morning to all present over here. Now today what we are going to see about Abina, we are going to see about an rotary variable differential transformer. Okay. The thing is to be that in rotary variable differential transformer, actually it is an inductive transducer. It produces an electrical output which is proportional to the angular displacement of the magnetic mobile core. The both the RVDT and LVDT workings are similar, but what will happen, Abina? The LVDT which employs the flexible iron core for displacement measurement, whereas in RVDT, whereas in the case of an RVDT, employs the cam type core. Okay, this core will turn among the two windings of the transformer using the shaft. So when you are saying about an RVDT, so which converts angular displacement to the electrical signal, and the input also what will given of Abina will be giving of an differential value of rotary variable, that is the angular rotation to generate the voltage output. Okay. So when you are saying about here, actually, so this is the diagrammatic representation of RVDT. So the variation from the LVDT is the only thing is to be that rotary core differential transformer. So the primary winding is wound on the center leg of an E core, and the secondary windings are wound on the outer legs of the core. The armature is rotated by an externally applied force about a pivot point about the center leg of the core. When the armature is displaced from its reference or balance position, the reluctance of the magnetic circuit through one secondary coil decreases, simultaneously increasing the reluctance through the other coil. So RVDT transistors will have a two windings similar to a normal transformer with primary and two secondary windings. The two windings of the transformer wounded, the two secondary windings will have an equal number of windings. So these are located on both sides of the primary winding of the transformers. Okay. So a cam formed a magnetic core which is made with a soft iron coupled to a shaft. Thus, this core can be twisted among the windings. The construction of both RVDT and LVDT will be similar, but the main difference is only the shape of the core in transformer winding. So this core will turn between the two windings of the transformer due to the shaft. The typical RVDTs are linear over a plus 40 or a minus 40 degrees. Sensitivity is about 2 millivolts to 3 millivolts per degree of rotation, and the input voltage range is around 3 volts RMS, and the frequency ranges from 400 Hz to 20 kHz. So when you are saying about that, actually, the thing is to be that the induced EMF in the secondary winding, which are equal in the reference position of the armature, now different in magnitude and phase as a result of the applied displacement. The induced EMF in the secondary coils are made to opposite each other, and the transformer operates in the same manner as an LVDT. The rotating variable transformers may be sensitive to vibration. If a DC output is required, actually a demodulator network can be used as in the case of an LVDT. A rotary core differential transformer has an E-shaped core which carries the primary winding on the center leg and the two secondaries on the outer leg. The armature is rotated by an externally applied force about a pivot point about the center leg of the core. When the armature is displaced from its reference or balance position, the reluctance of the magnetic circuit through one secondary coil is decreased, increasing the reluctance to the other coil. The induced EMF in the secondary windings are different in magnitude and the phase as a result of the applied displacement. Okay, so when you are saying about an construction, so actually it has a two windings, primary and secondary windings. The primary and secondary windings are wound on a former. So there are two secondary windings which have an equal number of turns. So these windings will be placed on either side of the primary winding identically. So a cam-shaped magnetic core made of soft iron is connected to a shaft. So this magnetic core which can be rotated between the windings. So the thing is to be that when you are saying about an working principle, based on the moment of the shaft in the transformer, the three conditions will be produced. So when the core is at null position, when the core rotates in clockwise direction, and when the core rotates in an anti-clockwise direction. So when you are saying about the reluctance seen by the primary EMF, which changes with the rotation of camshaft, this results in changes in the magnetic flux with the rotation of the camshaft. Due to this change in magnetic flux with the rotation of cam, the flux linkage of secondary winding which also changes. So therefore, as per the transformer action and EMF is